See, describe the use of resampling, bootstrap, and jackknife to estimate the sampling distribution of a statistic. Okay. So, what is this like resampling all about, Abhijit? Any clue? Taking the sample of a sample, correct? So, if we go with some example here, can we take what is this statistic all about, Abhijit? We take a sample and from that sample we find out the mean of that sample, correct? So a statistic or sample statistic is any quantity computed from values in a sample which is considered for statistical purpose. So if I can take mean is nothing but a statistic, na? Correct or wrong? Or estimate, fine, for a population, estimator for a population. So as we were discussing some point here, so we will take resampling here. What we'll do is we'll take a population. We selected a sample out of this. Again, we are taking a sample out of this. This is nothing but resampling. Okay. So resampling is a statistical technique which multiple new samples are drawn from a sample or from the population. So what is the statistics of interest here for us? Sample mean. Okay. So like or sample median, we calculate that for each sample, and the distribution of new statistics can be analyzed to investigate different properties. Okay, so what are we doing? Why are we doing resampling here? Maybe we were not satisfied with our sampling from the sample what we collected. Again, we are collecting some sample. Maybe here we found out the sample mean, which was somewhat biased. So we went for median, because mean can be mean gets impacted because of extreme observations. So again we did a resampling, we collected a sample and we found out the median for that, correct, sample median. And this sample median, whatever we have calculated, we will be having lot of values and we can make a confidence interval. Okay, and in that way we can make ourselves confident that the range of values in which our parameter lies, correct or wrong. For this purpose we are doing resampling. That means to recheck the bias, to recheck the error, or again we are skeptical, we are doubtful about the samples what we have collected, we are not getting accurate answers, we are doing resampling for that purpose. Now, in this, there are two techniques. One is jackknifing and one is bootstrapping. So what is this jackknifing? This technique is nothing but a resampling technique. Why we use it? Because we use it for finding standard error, variance and bias of estimators. Okay. It's a resampling technique. Especially useful for finding standard error. That means resampling technique, again we have collected samples to find out the errors. Okay. Variance and bias of estimators. That means the mean what we have already calculated. It is a small and handy tool. One more thing, what we do in jackknifing is we leave out one of the like observations from the sample. Okay, that means we skip it, we remove it. That is also one of the reasons that this is also called as leave one out method. Okay. And this approach tests that sum. See, what are we trying to do here? We are collecting samples from sample and we are trying to remove those things which can be the reason for bias. Some outliers we are trying to remove, or we are trying to find out sample median. Okay. If you remove the outliers, of course, your bias would be reduced, your errors would be reduced, correct? I hope you are hearing my voice. When I'm asking you correct, you're not answering anything. I did not hear really. So this approach tests that some outlier data point is not having. That means if we leave that out, we really ensure that that may not have an impact on our sample because of which the bias is created. So some outliers and data point is not having a disproportionate influence on the outcome. Okay. Now, so now the next thing is the jackknife deletes each observation and calculates an estimate based on the remaining n minus 1 values. Now it uses this collection of estimates to do things like estimate the bias and the standard error. That's what. Standard error. Okay. So here we delete and we find out we remove the things which can create the bias. Okay. And then again, the samples what we have will not have any bias. And then we can find out our estimates. Okay. So this is nothing but in fact done for correcting the bias, correction of bias. Now let's go for the bootstrapping. See, bootstrapping is what, like there will be a boot and you will be putting your straps, and again you will be like there will be many holes and you will be going on putting those straps, correct? So for what reason we are doing bootstrapping? It is useful. It is a useful means of assessing the reliability of your data. That means how reliable your data is. Example, confidence interval, bias, variance, prediction error, etc. So what here we are doing is, you should be very clearly understanding this. We use the method of replacement. What we do? It refers to any metric. Same thing like in Jackknife we are removing one thing. In this we are doing with replacements. Okay. That relies. It refers to any metric that relies on random sampling with replacement. So it is used to estimate, same thing, standard error, confidence interval, and test for significance. So do you have idea about this, what we say, with replacement, Abhijit, what happens in with replacement? Any idea? Yeah. Like when we have some, like if I take some marbles, let's say, if I take some marbles, I can easily see like what is with replacement and without replacement. No? Suppose I have some collection of marbles here, like green marbles. I'll just put green, and some green marbles and some red marbles. Okay. And like some blue marbles. So this is so the quantity what we have is total, let's say 15 marbles. Okay. And what we want to see in this is, in this 15 marbles, there are 6 red marbles, there are 5 blue marbles, and there are 4 green marbles, let's say. So if I speak about with replacement, and here we were discussing about what, in case of this one we were discussing about with replacement or without replacement? Replacement. In case of bootstrapping. Hello?
Oh, yes, I heard the question.
We were discussing about with replacement, correct? So now in with replacement, what will you do? Suppose if I ask you the probability of drawing red balls from this box. So probability of drawing red balls will be 6 out of 15. Okay, with replacement. Again, what you'll do is after drawing the ball, you'll be keeping the ball in the box itself. And again, still you have 15 balls. So blue balls will be 5 by 15 and green balls will be 4 by 15. This is with replacement. But when it is without replacement, what you do is you simply pick out one ball and keep it outside. So probability of drawing red balls is 6 by 15, but the probability of drawing blue balls will be 5 by 5 by what? 14. Okay. And then again 4 by 13. It goes in that way. Okay. So both the methods are there to check. One is there to remove the outliers and reduce the bias, and this is to check the reliability of the data, how reliable the data is, and like how you can kind of trust the data. Okay, this is what is about bootstrapping. So it's a big process, but really speaking, that much is not there in your syllabus and not required at all. Bootstrapping is not something which is like very small thing. It's a big process. A lot of samples have to be collected, and then you can use this programming also, Python, for doing that. Let's say what they have said about bootstrapping. A bootstrap method is more computationally demanding, but has some advantages. To estimate the standard error of sample mean, we draw repeated samples of size n from the full data set. So what we do to estimate the error of the sample mean, that's what we are doing here. We want to find out the error in a particular the samples what we are collected, and the mean which we have calculated. In that we have to find out the error. So we draw repeated samples. We take many samples, as I said, red ball, green ball, like that. We take many samples from data set, replacing the sampled observations each time. That means one sample we will remove. Okay. We discussed this. No, this now right now I explained you with replacement or without replacement. So this is done.
Yes.
With replacement. Okay. So we will study that, and again we will and we already have discussed with replacement and without replacement what is the difference it makes. So this is what we will be following with replacement. We will be picking out, studying that particular sample, again putting it here, again picking out, again studying, again putting it here. Like that we'll be doing n number of times. So we draw repeated samples of size n from the full data set, replacing the sample observations each time. We can then directly calculate the standard deviation of those sample means as our estimate of standard error of the sample mean. That means again resampling and again rechecking the things, okay, with replacement, and again estimating the standard error of the sample mean. So bootstrap method can improve accuracy compared to using only data in a single sample. That's what. So again and again, if you are doing that, it will give you more accuracy about your results, what you desire from that. Okay. So this can be used to construct confidence intervals for a variety of statistics in addition to mean, such as median. It can be used to estimate the distributions of complex statistics, including those that do not have any analytical form. Now, last and final question of this. Describe the issues regarding selection of appropriate sample size, data snooping bias, sample selection bias, survivorship bias, look ahead bias, and time period bias. So bias is nothing but something we are overestimating, something we are underestimating, we are doing some errors that creates a bias. So let us check the first one. Data snooping occurs when analysts, so what you do is you repeatedly take the same database. You use the same database to search for patterns or trading rules until one that works is discovered. For example, empirical research have provided evidence that value stocks appear to outperform growth stocks. Value stocks are nothing but some which has created value for the investors for a longer period of time. Okay, growth stocks are temporarily, they grow and give some temporary returns, but value stocks always constantly or consistently give you values. Correct? That value stocks appear to outperform growth stocks. Some researchers argue that this anomaly, that means this kind of statement, which is something which creates a confusion, is actually the product of data snooping. Why? Because they are repeatedly what they are doing, they are using the same database to search for patterns or trading rules until one that works is discovered. That means something should work out for them, and they always are stressing that value stocks always outperform the growth stocks based upon their database what they have, and they repeatedly using the same kind of database. So because the data set of historical stock returns is quite limited, it is difficult to know for sure whether the difference between value and growth stock returns is true economic phenomenon or simply a chance pattern that was stumbled upon after repeatedly looking for any identifiable pattern in the data. So again, reusing the same thing and repeatedly using the same thing will give you repeatedly the same kind of result. That's what happens in data snooping, whereby they always put more weightage to this and they are always like having a data much more like always they are having this data which they repeatedly take, and they give their feedback on that. Now, data snooping bias refers to results where statistical significance of pattern is overestimated. That's what they're overestimating always something. That is, they are overestimating value stocks. Okay, because the results were found through data snooping. So, when reading research findings that suggest a profitable trading strategy, make sure you heed the following warning signs of data snooping. Evidence that many different variables were tested, most of which are unreported until significant ones are found. There was some evidence which said that there were many variables which were tested, but many things did not get reported. Okay, so did not come to the light. And maybe we missed out something if something is unreported. So maybe because of that, some like growth stocks can be something which can outperform the value stocks, but such data they may not have, or such data has not been reported maybe. So these people are not able to get not able to change their ways. Okay, so the lack of any economic theory that is consistent with empirical results. That means they are always taking the past results and again with the same thing they are always trying to draw their own conclusion from their own data set what they have. Sample selection bias occurs when some data is systematically excluded from the analysis. They don't take it at all. So if you miss out something, then definitely that may have relevance. Maybe that may have relevance, but you have not taken that. You have excluded that. So when you exclude something which is of relevance, maybe, then definitely that cannot give you clear picture of what you are looking for. Okay, maybe for example, this can be a non-random kind of see, sample selection bias means you are selecting only those things which you want, and you are excluding those things which you may not want. This is kind of non-random sampling, and hence there can be a bias. Non-random sampling, non-probable, non we can say non-probability sampling kind of concept this seems to be. And when there's a non-probability sampling which comes into picture, there's always a chance of bias or error. Survivorship bias is the most common form of sample selection bias. A good example of the existence of survivorship bias in investment is study of mutual fund performance. See, very important. Most mutual fund databases like Morningstar only include funds currently in existence. See, whenever you take a mutual fund or you take SIP plan, they only show what is giving good results. They don't show them which are not giving good results. Am I right? Which long time back that has become a history. So when we ask questions, can you show me 10 year or 20 years back data when what kind of funds you had, your company's performance, and also they don't want to show that. Why? Because they only show what is in trend and what is surviving right now. Are you understanding? Hello?
Yes, sir. Yes, sir.
Lower returns ones people will reject. So what people have rejected, they don't want to show. What people have accepted, they want to show. So that means you're not collecting all the samples, no? So that means when you're skipping some of the samples which you would have taken and given average returns of your mutual fund, you're not doing that. So your mutual fund average is not trustworthy. That is a bias. Look ahead bias occurs when a study tests a relationship using sample data that was not available on the test date. For example, consider the test of a trading rule that is based on price to book ratio at the end of the fiscal year. Stock prices are available for all companies at the same point in time, while end of year book values may not be available until 30 to 60 days after fiscal year ends. So that means it's a study which tests a relationship using sample data that was not available on the test date. That means when we want to do a test, we had some data which was not available with us. So then what is happening? Then what may we do? We may either estimate that this is going to be the same, this is going to be our data, which may estimation may not be correct. Am I right? So I estimate that some data like the book values will be available to me within 30 to 60 days. So I say that my some particular asset or something I'm taking into picture. Let's say my investment I'm taking, my investment's book value is so and so. that I need to estimate now until and unless I have the data, accurate data with me. So my estimates can be over and under. So that can again create a bias. Time period bias can result if the time period over which the data is gathered is either too short or too long. Okay, that means when we wanted, that means we want to do some research, we are considering some time period, maybe we consider too short time period. Okay, and that gave us some result which is now questionable based upon you. I took 3 years to study. Then someone may question me, no, I don't find the accuracy of result. Why? Because minimum 5 years should be considered. Or maybe for this kind of data what you have picked or the phenomenon what you are looking for, 10 years was something which you should have taken. If I want to study the population of a country, I collect some samples. So 10 years reports are generally considered like standard reports. Am I right? Census, isn't it so? Hello.
Yes, yes.
In that case, if I take only 5 and 3 years data, then definitely it's time period bias. Okay. So Abhijit, sampling is done. Now we are in more safe zone. Only what I want is reciprocate. You should reciprocate by doing questions. Much of your fear is like about to end by this chapter. This is a very simple one. Need not worry. One class is enough. This will take at least 2 sessions, 2 to 3 sessions at least, because it's the biggest chapter of this book, stats book. So we will start this when, Abhijit? Tomorrow evening? Are you available? Or weekend, Saturday, Sunday? I'm not able to hear your voice. I'll call you better. 2 minutes.